Hello everyone. In this lesson we will start with our second lesson in the course Mastering Engineering Statics. This lesson is Statics Fundamentals. So we will study some fundamentals and key points related to statics. First of all, we will mention the units. Okay, in the mechanics we have four quantities used in this course. The first quantity is the length, second one is time, third one is mass, and fourth one is the force. Okay, these quantities are used in different units, and that will lead us to the second point, which is the systems of unit. We have more than one system of units, but the most common one is the international one SI, and the one is the US one FBS. In this course we will use the SI, but in some courses they might use the other one that used in the US. Okay, the SI is the meters. We use in the SI the meters for Newton for the length, the seconds for the time, the kilogram for the mass, and the Newton for force. Then we will jump to Newton's laws of motion. For Newton's laws, we have three different laws. The first one is describing the object when it's at rest, when the object is at rest, or in uniform motion, so there's no acceleration, in a straight line, unless acted upon by an external force. So it's describing the object when it's at rest or in uniform motion. Like this, for example, these stones, as we see them here, they are at rest, they are not moving at all, unless there's an external force acted upon them. So if there's an external force, for example, wind came here or someone pushed them, so in that case they will move or they will change. So this is what the first Newton's law, Newton's law describe. Now the second Newton's law. The second Newton's law, we have a formula for the second Newton's law, which is the force equals the mass times the acceleration. Okay, as we know that in statics the acceleration equals to 0 in statics. So that's why this formula won't be used with us from the second Newton's law. But we can get this formula from Newton's law, which is the summation of forces. We have very common two formulas that we will use in this course, which is the summation of forces in y-axis equals to 0, and our assumption when they are moving right side to the right side they will be positive, left side they will be negative, and summation of Fy equals to 0, upward positive, downward negative. These are very important and they are very useful in this course. Also, we have the second formula that we will use is the summation of moments. So for example, the summation of moments around any point equals to 0, and the assumption it will be counterclockwise, rotation counterclockwise positive. However, these formulas are we will just see them now, but later on when we are studying this course and we will have more examples, we will know how to use these three equations or formulas. Let's move to the third Newton's law. The third Newton's law says for every action there is an equal and opposite reaction. For example, we have a body like this, and someone is carrying, and this body is 10 kilogram. Someone is carrying this body here, and the other one is carrying this body here. So this one will carry with 5, and this one will carry with 5. So for every action there's an equal. We have this action, the table, 10 kilogram, and two people are carrying this table. So an equal and opposite reaction. We have 10 going downward, so we have equal to it, 5 and 5, 10 again, equal to the 10, and in the opposite reaction. This one is going downward, this one is going upward. This is what the third Newton's law say. Okay, then we have the free body diagram. Free body diagram is very important in this course because we isolate the objects in this course in the analysis procedure. It's important to isolate the objects and to get the values and the forces in each part or in each object. So the title of the free body diagram or the definition is: this diagram is to isolate objects and identify relevant forces and moments when we isolate them. So we have this example. We have this, let's say, a book and a table. So they are together like this. When we want to identify the relevant forces, we have the weight of the book, also we have the weight of the table, and we have the forces from the supports came from the floor. As we know, here we have a floor and we have the columns of the table. So we have forces here pushing the table upward in order to stay stable. So this is the first point. This is the first free body diagram, and then we have the second free body diagram. We can also divide it more. We can divide the book by itself and the table by itself. So the book, we have the weight of the book and we have the force of the table that is pushing the book. Also here on the table we have the force of the book, which came from the weight of the book itself, and also we have the weight of the table, and we have the force of the floor, the supports here again. This is how to divide and how to analyze the forces in the using the free body diagram. Okay, and let's jump to the last point: types of forces. This is very important to understand the types of forces in this course. We have different types of forces and they act differently. So first of all, we have the point force. Point force are like the 20 kilonewton here we have. So point force is acting only on a specific point, only one point. It can be here, it can be anywhere in the shape, but it acts like a point. Then we have the body force itself. The body force is also described as the weight. Weight of the body also is the body force. So as we know, we have this member. This member has a weight. This is the second point. Okay, third one is the reaction force. Reaction force, here we have this reaction and this reaction carrying this beam. So here we have, for example, we have AY, and AX. And here we have BY. This is these are the reactions we have in this shape. Okay, and the last point is the distributed force. As we see here, this 40 is distributed on the 8 meters. It's not concentrated like the 20 here. It's distributed on the 8 meters. That's why it's called distributed force. Okay, we still have one thing in this figure, which is the 150 kilonewton. This is the moment. The moment is different. It's not a force. The moment is something related to rotation, and it's what causes the rotation to the member, but it's not a force. Okay, thank you very much. See you in the next lesson.